Hi Year 12s, this is some help for the homework in case you wanted me to walk through some of the solutions. Okay, right, so we have a function, f of x is a quadratic. If we know that f of 1 is 2 and f dash 2 is 12, find the values of b and c. So this is just the straightforward substitution into the function. Let's try that first. So f of 1 would be 1 squared plus b times 1 plus c. So that simplifies to be 1 plus b plus c. And we're told that f of 1 is 2. Okay, so I'm going to just keep the b and the c on one side and subtract 1. Okay, so we have an equation. But there are two variables there, b and c, so we don't know what each of them are. And only one equation. Right, f dashed 2. So that means differentiated, okay, and then substitute in 2. So we always differentiate before we substitute in. So first of all, we differentiate f of x. So bringing down the power, we've got 2x plus, now remember, b is just a number that we're going to find out. So we're differentiating the x, that will give us 1, and it's times b. And then c is just a number that we're going to find out. If you differentiate a number, you get 0. So now we can work it out when x is 2. So we've got 2 times 2 plus b. And so that is 4 plus b. And we know that that equals 12. Now that is fabulous because we only have one variable for that equation, so we can solve it. So we're going to get b is equal to 8. And once we know that b is 8, then we can substitute it in here. So we've got 8 plus c. So that then gives us that c is negative 7. Okay, so b is 8, c is negative 7. Okay, question 6. We've got two parts. Find the gradient of the curve at the point where it crosses the x-axis. Okay, so to find a gradient, remember we're differentiating. So we've got if y is 3 root x minus 2, we want to differentiate that. Now I don't like that at the moment because that's a root, so I'm going to rewrite that as 3x to the power half minus 2. So now I can easily differentiate that. Now notice I'm not putting, so I've got y is equal to this, I'm not just putting equals now, because that is y and this is the gradient. So a bit of a bugbear. Lots of people just put y equals this equals the gradient, and that's rubbish. Right, so we've got 3 times, we bring down the power, so we've got 3 times a half x to the minus a half, and when we differentiate 2 we get 0. So we've got 3 over 2 x to the minus a half. Right, now it says we want to find it at a particular point, so where it crosses the x-axis. So we've got some kind of curve, okay, and where it crosses the x-axis, we know the y-coordinate, don't we? We don't know what the x is, but we know the y-coordinate is 0. Okay? Now that helps us because we can use the original relationship between x and y to find out what x is. Okay? So that then tells us that we've got 0 is 3 root x minus 2. So 2/3 is root x, and so if we square both sides, we get 4/9 is x. And now we can substitute that in. So actually, we're working out the derivative, the gradient, at x is equal to 4/9. Okay, so we've got 3 over 2 times by 4/9 to the negative a half. Now you might remember that's the reciprocal and the square root, or you can type it into your calculator. And if you type that into your calculator, you're going to get 3 over 2. And so our final answer is 9/4. Okay, so the gradient of this curve, we had to differentiate to get the gradient, at the point where it crosses the x-axis. So we had a little think about crossing the x-axis here. we use that information to find out where it crosses the x-axis. We then put that into our gradient so we could find out what the gradient was at that point. Okay. Now for part B, is the function increasing or decreasing at this point? So it's increasing if the gradient is positive. So 9/4 is greater than 0. Therefore, the curve is increasing at 0. Okay. Okay, number 7. Find the range of values of x for which the function blah 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 is increasing. So it's almost the same as the previous one, but kind of in reverse. Alright. So let's, first of all, we want to find out where it's increasing. Now it increases where the gradient, oops, I'll put as dy by dx, because we've got y here, is greater than 0. So the gradient's positive. So let's differentiate. So dy by dx is equal to 3 times 2x minus 4. Okay? Now that's going to be greater than 0. So that then tells us that 6x is greater than 4 and x is greater than 4/6, which is 2/3. And that's it. Short and sweet. Alright, this is back to front of the previous one. So we've got another quadratic. We're told it's increasing when x is greater than 5. So we've got the answer, and we need to find out what this mystery number a is. Okay, so we do the same thing. So increasing, the gradient is positive. So that means dy by dx is greater than 0. So let's differentiate. So we have 2x plus mystery number times x. So that just becomes mystery number minus 7. When you differentiate that, you get 0. And we know that that has to be greater than 0. So let's try solving. So we've got 2x is greater than negative a. So that means that x is greater than minus a over 2. Now we know that it has to be that x is greater than 5. So that then tells us that minus a over 2 is equal to 5 and a is equal to negative 10. Okay, differentiation from first principles. So you get given that the gradient is equal to the limit as h tends to 0 of the original function a little bit further on minus the function at the point divided by h. Okay, so you get given that. So for this question, our f of x is equal to x cubed minus 5x. Okay, so dy by dx is going to be the limit. We have to keep writing that. H tends to 0 of, now wherever we're placing an x in here, we're now going to place an x plus h in brackets. So I've got x plus h cubed minus 5 lots of x plus h. Then we're taking away the original function, so x cubed minus 5x all over h. Right, that's a lot of brackets to sort out. We still keep putting the limit, so we deal with that at the end. So you might need to take your time expanding that, but you'll learn some tricks for doing it quickly. So I know that's x cubed plus 3x squared h plus 3x h squared plus h cubed minus 5x minus 5h. And then we've also got, for now space, minus x cubed and plus 5x, and that is all over h. Should have planned that a bit better, shouldn't I? Right, so let's have a little look. We've got an x cubed and a minus x cubed, so they vanish. It's good news. We have got a minus 5x and a plus 5x, and then everything else involves h at the minute. So let's just see. So 3x squared h plus 3x h squared plus h cubed minus 5h. all divided by h, so you can, I'm going to factorise to kind of be very proper. So I'm taking h out as a common factor. And that means that I can cancel my common factor on the numerator and denominator. Okay, and then finally we can allow h to go to 0. So in the limit as h goes to 0, we are left with, this doesn't have an h in it, so 3x squared. This has an h in it, goes to 0. This has an h in it, goes to 0. This doesn't. So we've got -5, which is super. That's all we wanted.